So I'm going to quickly present a brief summary so that if there are some people who have joined now, then you can get a quick summary based on the next 2 slides. Okay, so far, what we've said is that we care about multiple stakeholders, and we want to look at their objectives. So each stakeholder could have multiple objectives. We have looked at some methods for multi-objective recommendation problems. We have included, like, this is the section which we recently ended. And now what I want to pitch is that while you develop your core solution, which is a multi-objective solution, let's develop some supporting modules around that so that you can make better informed decisions in real time. So again, the summary of first part, that traditional recommender systems have mostly catered towards user-centric modeling. Multiple stakeholders are present in online platforms. So we need to consider multiple objectives, and we need to have ML models which optimize those multiple objectives. So that's what we saw in the first part. In the second part, we looked at 7 different case studies from different industries. We looked at what some of those stakeholders are in these companies, what some of those objectives could be. And then we did some analysis on the interplay between objectives. So they can be conflicting, they can help each other out, they could be positively correlated or negatively correlated, and so on. So we've pitched the need for ML methods to model the interplay between those. And we've also pitched the idea that it's important to carefully decide what a system optimizes for. In the just concluded third part, we've looked at some flavors of multi-objective approaches. We've looked at multitask learning, scalarization, multi-objective version of multitask learning, bandits, and multi-objective RL. So essentially, like, again, I'll re-emphasize now that if you have to take away one business decision from this, then it should be the last point, which is it need not be a zero-sum game. There might be gains possible in your business objectives without hurting your core user-centric objectives. Cool. So for the fourth part, what I want to do is, like, I want to touch upon, again, the way I want us to imagine this is that we have a central system, which is a multi-objective model. And now we have some supporting systems around that model, which will help make the central system do a lot better. So how do we do that? So we do that by leveraging understanding about the user, about supplier, and about content. So I know that at the start of the tutorial, we did mention that this is inherently a multi-stakeholder problem. And our understanding about the different stakeholders should guide us towards better algorithms. So here, what I'm going to talk about is I'm going to literally talk about 6 different projects. I'm not going to go into specific details for each of those, but instead we're going to look at, from a bird's eye view, some of these results and why understanding about consumers should help your overall recommendation problems. So specifically, we're going to start with consumer understanding. We're going to look at some user-specific traits like consumption diversity of users, user intents, and user receptivity. We're going to then go to supplier diversity and then look at some content understanding gains. So the first part is around consumer understanding. So consumer is a user, and in the user understanding world, what we want to do is we want to understand how much a user wants diverse content. So this work is coming in from the WWW paper we had earlier this year on algorithmic effects of diversity of consumption. So here we make a point around user groups. So essentially, what we say is that some users are specialists, that they care about, they only want to listen to some specific form of content music. And some others are generalist, like they have a wide horizon of the kind of content they consume. So we can divide users on this spectrum from 0 to 1 as to how specialist versus how generalist they are. And a similar line of work has been done also in the Reddit community as well. So what we see is, like, we see very specific behavior, that generalists and specialists exhibit different retention and conversion behaviors. So yeah, that's a good point. So Hussain mentioned that specialists could be heavy metal fans. I'm pretty sure there are like heavy metal fans who have pretty wide array of music history as well. But yeah, I mean, look, this is music. We had a lot of fun doing this work. And actually, just worth mentioning, this work is led by Ashton. So Ashton is, so he's a part-time Spotifyer, and he's a faculty member at University of Toronto. So we also do a lot of like academic partnerships at Spotify, and that has kind of helped us shape our research and product as well a lot. So yeah, just on that note, again, like the findings from this paper says that different users have different consumption behavior. So some users really like diverse content, some users don't. And users' consumption diversity could be a fact, could play a role in like what kind of content we show to users. The next thing is about user intents. So we had a paper at WWW last year on understanding intents. Now, intent is super hard to understand in the recommendations domain, because if you're in search, then on search, the moment you type in a query, the system knows what you want. But let's say if you go to Netflix, the homepage, or if you go to LinkedIn, or if you go to Spotify, then when you're on the homepage, we do not know what your intent is right now. I mean, it's very hard for systems to infer intent because there is no text which you're typing out. So intent understanding is a hard problem. So we tackled that in this paper. There's also some work, nice work from Pinterest on looking at, I think it's the WWW 2017 paper, the web conference paper in 2017, which talks about like understanding intents on Pinterest without any text, but like interaction-based intent prediction. So here, what we did was we did some user research, we did some qualitative analysis and some prediction models. And finally, we came up with a list of 6 to 7 intents users might have on the homepage. But again, not going into specifics, but then we said that, hey, I mean, if we want to do prediction of satisfaction, right? I mean, I want to know how satisfied my users were. So I can do that globally, or I can do that for each intent. So this is the difference. So let's say we do a global model. So global model is a single satisfaction prediction model across all intents. Then the problem is that's going to miss out on a lot of intent-specific nuances. That often interactions are based on intents. Like if you really want to create a playlist, then you won't listen to songs, but then you just sample songs, add to your playlist, and then go on and hunt elsewhere. So that intent behavior is very different from other intents. So that's why a global model is not really that great. A per intent model, on the other hand, is great because it has information on each intent. But the problem there is that, I mean, we may not have enough data for each intent, right? So that's why we propose a multi-level intent model wherein you're doing some global learning and some intent-specific learning. At the same time, you're sharing information across intents. The important takeaway here is that considering intent information was crucial. So in offline evaluation, it gave us like about 20% improvement in SAT prediction over a global model. So why is it important? So this is important because this result shows that user interaction is intent specific. And if the interaction is intent specific, then if in a multi-objective, in a multi-stakeholder world, if the user right now wants to create a playlist, that scenario is very different. So I mean, if a user wants something really quick, that hey, I'm in a party and I want to listen to some party music, then I have some less leeway in what content I could recommend to the user from other stakeholders, other objectives. So that's the key point. Like understanding user intents will really help us to make sure that we are surfacing information from other objectives which do not hurt or are not in like competition with the user intent as such. So the summary being like user intent information can help us do better targeted recommendations from other objectives. The final thing is something which was recently accepted to Rex's as a late breaking result is user receptivity. So we've talked about users. We've talked about like, hey, I mean, some users want diversity, some users don't want diversity. But in this paper, we specifically address this question that how receptive are users? And is user receptivity something which we can quantify? Is it something we can predict? And is it something which we can use? So essentially what we did was we looked at we did a randomized A/B test on the homepage, and we used that data to quantify and predict user receptivity. So what is user receptivity? So user receptivity is a way to understand how okay are users when we distort their recommendations. So this distortion could be that, okay, I really have to get the artist or some retailer diversity metric up. So I'm gonna not show you the most relevant content, but I'm gonna show you some content which will help me improve the other objective, right? So So there, some users might be okay with it, some users might not be okay with it. So that's there. If we know that this user is going to be receptive, so then we can use that information in the multi-objective models, which we talked about. So for that, we looked at like different ways of quantifying receptivity, like engagement-centric, effort-centric, and stickiness. And we use some features to train a predictive model. Again, like nothing fancy, but the core point here was that is user receptivity predictable? And we found out very interesting things that different users are differently receptive. I mean, some users are really more receptive, some users are like not receptive at all. And that's interesting because if your multi-objective model knows that this user is not receptive at all, then it dare not show other stakeholder objective-based recommendations to that user, right? So then you can avoid a lot of dissatisfaction metrics in your overall like performance. We also found that there are features which predict user receptivity, and consumption diversity is not the most predictive. And this was a very surprising result because, I mean, at first, at least like I had the intuition that users' consumption diversity should give a good indicator that are they receptive to distortions or not. But it turns out that consumption diversity is not one of the most predictive features of user receptivity. And then like we can get up to like 70% accuracy in predicting engagement style receptivity. So just a quick summary of just consumer understanding. So I've talked about 3 projects, looking at users consumption diversity, looking at intents, looking at user receptivity. Why should I care about this in a multi-stakeholder marketplace problem? So the point over here is that understanding users helps. In the first case, we know that there is a strict user level heterogeneity. So that means some users will behave differently than some other users. And I should know that when I'm designing my multi-objective marketplace solutions. In the second case, looking at intents and having the ability to identify intent real time is going to be super important, especially when we want to surface content from other stakeholder objectives. Now, some intents will have a high amenability to show content from other stakeholders, whereas some intents are like really specific and you dare not do anything apart from that in those specific intents. So having that intent understanding helps, again, design better marketplace matching algorithms. And of course, like the understanding user receptivity is one of those top-notch things you should do. Like, again, your ML models should be aware. Like we've talked about RL models, we've talked about bandit models, which decide how much weight we should be giving to some of these objectives, right? So there should be a user level input to that process. That this user is not receptive, we should not show them content based on any other objective than user satisfaction. So that's a quick summary of some findings from user understanding. Quickly going into a couple of projects on supply understanding, and I want to make sure that we have enough time. We are slightly behind schedule. So in supplier diversity, this is the paper I mentioned briefly. This is a second paper looking at a trade-off between relevance, user relevance, diversity, fairness from the supply perspective, and user satisfaction. So again, like we consider 2 stakeholders, relevance and exposure fairness. I've shown this plot before that we know that on the x-axis, we have the diversity and fairness of suppliers. On the y-axis, we have the user relevance. And there is no set on the top right, which means like we don't have a lot of sets which have both high relevance and high fairness. So there's a trade-off. Like had there been content on the top right, then we could have just shown that and both the metrics would have improved. But now we have to make these trade-off decisions. So how do we trade off user relevance and supplier diversity? So in this paper, I briefly mentioned some of these before. Like we can optimize only relevance, optimize only fairness, have a probabilistic policy. We can do a trade-off, like just do a weighted sum. Guaranteed policy is something which I think some of you were asking before. That can we do? I think Dima was asking around like constraint optimization, right? So let's look at policy 5 here. So policy 5 says that I'm going to guarantee that the recommendations I show are not going to be relevant less than 0.8. So the relevance value is guaranteed to be above 0.8, let's say. And once I give you that guarantee, then let me allow me to do whatever I want in terms of the other stakeholder objectives. So this is a very nice intuition to think about constraint optimization solution. That as long as you can give some constraints and satisfy some constraints. I'm going to allow you to do whatever you want. So that's a nice solution as well. We tried some other adaptive policies wherein we looked at some of these like user receptivity style scores, and then found that this really performs well. So again, not unexpected, like if you look at fairness versus relevance, the more relevant you show the content, the more your satisfaction is. But interestingly, there's an inflection point, which gives me a good trade-off, right? That in general, I can get enough gains in my fairness and diversity metric without causing a steep decline in my user satisfaction metrics. And interestingly, this is one of the important points. And this, I think somebody asked this question around consumption diversity and supply diversity. So if you look at some of these adaptive policies, so these adaptive policies are user receptive aware. So some users are receptive, some users are not. And based on that, we decide what kind of content I want to show. Do I want to show relevance content, or do I want you to show supplier fairness content? So interestingly, we found that in terms of the trade-off, this diversity aware policy is giving us the best trade-off. So a question over here is from Rolf on supply in this context related to artist. Yes. So the supplier diversity, the diversity here talks about supplier diversity, which is the artist diversity in this paper. But essentially, some users have a high affinity to supplier diversity, some users don't. So I mentioned about the receptivity paper before, right? That some users are okay with it, some users are not. So these adaptive policies take that into account, that some users are going to be okay with it. And if so, then let's push it. If not, then let's not do it. So essentially, what we found was that the supplier diversity method gives us the best trade-off. That it's going to give you the max gain in your diversity without severe losses in relevance and without like much losses in satisfaction as well. Now, this is very important because this says that we should consider users' affinity towards supplier diversity. So now we are kind of mixing everything in together, that we know some users like it, some users don't like it. So we have to quantify user affinity to something. And that something is supplier diversity. Quick answer, SAT is satisfaction. So SAT everywhere is user satisfaction. So any of the satisfaction metrics could be SAT. So essentially the main point over here is that the aspect of diversification is also personalized, which relates to the user heterogeneity point and the user receptivity point I made before. That diversity affinity is different from user receptivity. So there's a question from Hari around, so diversity affinity is one form of user receptivity, right? Because user receptivity to what? To random content, to popular content, user receptivity to tail content, or to diverse content. So you can define user receptivity is a philosophy, and you can instantiate that in any context you want. Some users want discovery, some users don't want discovery. Some users want diversity, some users don't want diversity. So again, so yeah, diversity affinity is a form of user receptivity. There's a question from you around user experience metrics like engagement and skips. Yes. So user experience, SAT, these are all like skip-based metrics. I mean, again, like internally, we have a lot more sophistications around like return rate, engagement depth, downstream impact, and all that. I mean, you don't just want users to listen to music and just go away. I mean, you want them to create meaningful connections. I mean, if we can make a user a fan of the artist, that's going to be really more powerful than just one track listen at this stage. So again, like internally, we have done a lot of work around that. If you're interested, right now, there's a parallel tutorial going on given by our head of research, Munia, around metrics of user engagement, which should talk about some of those aspects in more detail. But I want to get back to this point one last time and say that here we are starting to see that there's a user level heterogeneity, which we talked about. There's a user receptivity, which we talked about, and using them in the decision-making process. And now we are starting to see that, yes, this is indeed like a very powerful, and it gives us gains. So that's why this is why I want to kind of mention this point in this topic of part 4, that we want to leverage these things in order to make better decision-making processes, in order to make better multi-objective models as well. Quickly, and look, I mean, we've talked about artist from the user perspective, right? But But artists and suppliers, right? I mean, let's just abstract away. Amazon, we have retailers, we have suppliers. eBay, we have retailers. Airbnb, we have host. Uber, we have drivers, right? So in all of these platforms, we should care about suppliers, not just because they are linked with users, but also like there is a rich network of supplier interactions as well. So again, in this Rex's 2020 late-breaking results, we looked at the spillover effect. So if I do something on some supplier, then what happens to the other suppliers, right? Because this is a system. You're now working in a platform. And if you do something to somebody, others get affected as well. So far, we have been explicitly talking about interaction between users and suppliers. So we're talking about consumer supply interactions. But here, I want to drive home the point that there is a strong network effect on the supplier relationship as well. So essentially, in this paper, what we did was we looked at new track releases. I mean, it's just a running example to drive home the point. But essentially, we found that we looked at the causal impact of new releases, and if a focal artist releases a new track, then it has an impact not only on the focal artist but also on related artists. And there's a very nice intuitive explanation that suddenly, like, let's say Lady Gaga released a track and I like it, and everybody starts streaming it. Now, I mean, there's a specific genre of that track, so that kind of pulls strings in a global manner, so that users start to stream more and explore and discover more related music as well. So again, this is just a running example, but the key takeaway point over here is that other suppliers benefit or get harmed by virtue of being on the platform. So essentially, what this means is that there is interaction going on across suppliers, right? If you're promoting somebody, the others might get cannibalized. So or the others might benefit as well. So again, we have to be mindful of the fact that we're not just working on a user-supplier relationship. We also have to take into account the supplier-supplier relationship. So again, that's the implication here, that there is interaction within suppliers, and optimizing for exposure of certain artists might help other artists as well, as opposed to what we might believe otherwise. But importantly, there is a interplay between consumption across different artists and different suppliers. I'm going to pause for a quick 2 minutes and take a couple of questions. So are these results coming in from the A/B test? So the exact results reported in that paper, so yes and no. So the user receptivity work is coming in from the A/B test. The tolerance quantification work, that's a dated paper from 2018. That is not from the A/B test, but we have done subsequent test, and there is a paper which is under review right now, which has details from that A/B test. There is also some work on search around using some of this work, which I'm going to talk about in a bit, and that's also coming in from A/B test. So it's kind of a mix of yes and no. There's a question from Shi around, is there a need for predictive models for platform-side metrics like diversity, or are most predictive models around user? That's a good point. Look, I mean, so I want to make a point that the prediction models are not necessarily just user-centric predictions, right? User interaction predictions are something which comes naturally to our mind. But then what about like artist fan creation? Like how much fans is this artist going to have? Or is this artist going to be, how much popular will that kind of artist going to be? Is that artist going to, based on the current trajectory, is the artist going to make enough money down the road? Or in the Amazon retailer case, is this retailer going to have enough products on the platform eventually? Or are they going to kind of run out of products? So, I mean, Amazon, I'm sure, like cares about such prediction models as well. Like inventory management from the supplier perspective is a very important problem. So they have to have multiple prediction models around that. So again, like it's not necessarily that the predictive models are around just diversity, it's around supplier side as well. There's a question from Samir on evaluation of marketplace. Many criteria can be used. How do you choose your evaluation protocol in this setting to ensure reliable comparison? Yes, so this is a whole separate part of the tutorial which we had at Rex's, which we have kind of skipped in today's version. Evaluation, multi-sided evaluation is a super understudied problem, right? I mean, we showed some of the results wherein there was a radar chart that was talking about, hey, this much you're gaining on one objective, this much you're losing on the other objective. So essentially, do we have to look at like 5 tables? or do we develop composite metrics? So we started to do some work around developing composite metrics that can we link the losses and gains across objectives and across stakeholders together in a single number? Again, super hard problem. We were talking on chat about exchange rates, right? That how do I make sure that a 10% loss in satisfaction is equal to a 10% gain in an artist metric? So we don't. So again, this is related to that point, that right now we don't yet have, at least like in public research, we don't have models which are pretty good in like understanding the interplay between objectives and giving them nice exchange rates. And that's also harder because this is going to differ on a case-by-case basis. And also it's going to differ on a need-by-need basis. A product manager at one point can have more demanding revenue-centric goals towards the end of the quarter in some companies than other times, right? So again, like the exchange rates, the importances, they have a human and business element to it as well. So there's a question or comment by Ahmed. A metric like diversity is strictly a consequence of your recommendations. So yeah, that's a good point. Like diversity is a consequence, but also like, look, I mean, a diversity value of 4, right? It could, let's say proportion. So how many retailers are tail retailers? Is that 4 out of 10, 5 out of 10? So the metric could just be 4 out of 10 for multiple cases, but then they could be good diversity, they could be bad diversity. I mean, I can select a random set of 4 retailers and then show it to you. The metric will still be 4, but then is that good or not? So again, there is that like prediction element on the diversity being a good diversity to the user. Sumit has a question. To what extent the complexity of these multi-objective based bandit models pose limitation on putting models in production? Yeah, so again, so that really depends on the teams. So this is like a question on like, so we're talking about scalarization, like weigh them together, push it to production, easy thing to deploy, right? Or we're talking about a multi-objective bandit model. So again, a lot depends on the maturity of the ML team, and not all machine learning teams will be as mature as like the most advanced machine learning team. So we have like pretty nice sophisticated infrastructure to deploy these models. So again, a team which has these, it's easy to deploy. Essentially, you're kind of replacing one TensorFlow estimator by another and keeping it online. But it's not that like this is not a given. I mean, not all teams have the same amount of maturity in terms of like the infrastructure. And this is true for like across all companies, I guess, anyway. Some work bring down the objectives to monetary manner and then, yes, yeah, I mean, so Dima is from booking.com. And I'm sure like at Booking as well, like, again, a lot of these decisions on what gets shown to the user have some revenue-centric goals as well. So I don't know how much companies can comment publicly about these, but yeah, there are definite like trade-offs to be made there. And sometimes business governs that kind of value one thing over the other. But in the long term, like understanding the long-term impact of some of these things on user retention and user satisfaction, I think it's going to be key. Last question, if you have a composite online metric, would you use it as a basis for scalarization? That's a good point. Artem has a very good point that let's say we develop a composite metric. Should we just optimize for that? I don't know, to be honest. Like I would say that we might do some errors if we just optimize for that metric, because few things might happen. Like, so there is this element of user receptivity as well, right? Just that notion. So then we know that I can keep satisfaction neutral and I can get away with increased, let's say, diversity objective if I target these like receptive users, right? So this notion, the composite metric is not rich enough to encapsulate this information. So oftentimes I think like a scalarized approach is lacking in detail, whereas a multi-objective model has access to all objectives specifically, right? Whereas a scalarized, if you have a composite metric, if you optimize for that, you're bringing all the richness and then getting a one value out of it, and you're losing information. So you're leaving money on the table if you just optimize a composite metric model. So that's my take, but I think it's a very good research question to consider. I mean, if somebody knows that some work has gone into evaluating these, please feel free to add to the link. But if not, then I think it's a good question. But I would say that like, yeah, let's not scalarize if we can. I mean, there's a richness which is brought forward by the different objectives in each sessions. And let's not like diminish that richness by just aggregating into one value. But it's a good catch. Cool. So again, the summary part of where we are and how much time do we have? Cool. We're really running short of time, so I'm going to rush through some of these. So in terms of supply diversity, we saw that there is interplay between what users want and what suppliers we want to expose. And a causal impact we've seen on one supplier's events on related suppliers. So that means there is interaction across suppliers. And all of these things you should take into account when you're designing your multi-objective algorithmic balancing models. Finally, a couple of quick results on content understanding. So far we've talked about user understanding. We've talked about content. We've talked about supplier understanding. And now I'm going to pitch that, hey, when you're talking about users and suppliers, also keep in mind the actual content. So this paper is from www last year, like the web conference last year. So Paulo, who's now doing machine learning at Criteo, he was an intern with us in London, and this is work from his internship. So here we're saying that, look, I mean, if we care about, let's say we care about rewards. So in a contextual bandit model, we have to define a reward function, right? In a multi-objective bandit, we have to define a multi-value like vector reward. But let's just consider a single objective model for now. So in a contextual bandit model, we have to define a reward function. And here we try to play the pitch that your reward function should be aware of the user and content as well. So if you look at playlist, then consumption of a playlist differs based on playlist, right? I mean, if you look at the blue plot, it's the aggregate consumption of all playlists, and the green plot is consumption across sleep music playlist. And we expect like sleep music to be longer because, I mean, people should sleep. So the average consumption should be higher for sleep music. So if I do a reward function which says that, hey, I'll give you a reward if somebody streams for 5 minutes. So that single reward function is not good for sleep music because 5 minutes of sleep music is nothing. I mean, it should be more than 50 minutes perhaps. So that's why, I mean, we're starting to see that, hey, I mean, we should not have a fixed reward definition for all playlists. Same for users. We see that jazz listeners consume jazz and also other playlists for longer duration than average. So that means like there's a user level heterogeneity. So your reward function should also consider user. So this is where we say that we should now start to look into distribution-based reward functions. So the easiest thing to do is have a look at a global distribution that I don't care about users, I don't care about playlists, I just have a single reward function that if you stream more than X seconds or X minutes, I'm going to give you a +1. If not, I'm going to give you -1. Now, this is very restrictive because users are different, content is different. Ideally, we could have a user playlist personalized reward function. So each individual user and content pair would have a reward function. Now, that's not scalable because it's too granular, too sparse, too noisy, and it's very costly to generate and maintain. So this is where we could do co-clustering. So I'm going to look at users and content, and I'm going to group them into co-clusters. So co-clustering is not new. I mean, it's been around for more than 1.5 decades. So co-clustering, you have users and playlist. You look at their consumption over time, and then you co-cluster them. So now you have user groups and you have content groups. So then a group is a cluster. And in general, you're grouping users and playlists together to create a co-cluster. Now, what we can do next is we can look at distribution within that specific co-cluster, right? That instead of looking at global distribution of consumption, we can look at co-cluster specific distribution. And then we can define some sort of reward functions using these distributions. So it could be a simple mean-based or mean standard deviation or some exponential decayed reward function. So essentially what we've done is we've said that, hey, there is content, there is user, and there's heterogeneity in these. So don't have a very naive, stupid reward. Like consider your content and user when you're deciding your reward functions. And when we do that, we do see pretty significant gains based on our like real world streaming interaction data. So just co-clustering, just adding user clusters and content clusters is important. It gives like better results than global reward function. And then co-clustering gives like even better gains. Now this is important, right? Because here we are saying that there are content characteristics and using them makes sense because now you can do better, decisioning on what recommendations to show. Finally, this is something on the search which which is coming in. Again, this recently got accepted last month at CIKM. This is on looking at queries. So this is one of the only search papers I have in my tutorial today. But again, in this part of the tutorial, we're looking at how can we leverage content understanding, right? So what if we look at search? And if you go to Airbnb, search is important. If you go to Amazon, search is important because users consume a lot of content on search. And in there, what we want to do is we want to find out that are there certain queries wherein I could take a more relaxed approach and then push some underserved content? Or are there certain queries wherein like the user is very, very clear on what they want and we dare not change anything? So we've talked about user receptivity, which is a user level score. Here we are talking about a query level score. That in search, are there certain queries which are more non-specific, which we can use to maybe show some content from other optimization objectives? So essentially, the idea over here is that users might not have any specific preference. Example, relaxing music, right? If somebody comes and queries relaxing music on the platform, then, I mean, they've not asked for one specific song from Adele, right? So now we have the opportunity to surface some underserved content. So in this work, we focus explicitly on underserved content. So we looked at some content which we think should have kind of been exposed more, but somehow didn't. So then we try to find out opportunities where we could expose them without hurting user satisfaction. So essentially, we view this problem from a non-focused query perspective, that there are broad intent queries for which users are open to non-specific recommendations. So this is interesting, right? Because some queries are like, hey, I want Coldplay, that song, Paradise by Coldplay. So then we know what the user wants. It's a very specific request and we cannot do anything else. Oftentimes, there are queries which are non-focused and they are broad. So then we have some leeway to play around with this. So essentially, we focused on casual music and niche genres. And we then developed some query and user interaction features, which help us in kind of identifying such queries. So again, a lot of details I'm skipping. We trained some prediction models to identify such queries at scale. We did some A/B test around this, and we have some exciting results. So the first step, okay, how do you use this content understanding to get content from other stakeholder objectives surfaced? First of all, identify non-focused queries. Like these are queries for which we can do something. Surface recommendations, which help other stakeholder objectives, keeping in mind that we should not be hurting user satisfaction. Now, this is an English sentence, but this is a paper, a project in itself. Now that I have a query level score, how does my learning to rank model use that score to push other objectives, right? So this is a problem which is tying this section to the previous section. That so far we are talking about, hey, there are these multi-objective models, and now I have a query level score. How do I use that to inform how much weight you should give to some of the other objectives for this specific query? Because I think this query has the potential for us to show content which are coming in from some other stakeholders. And then like we want to understand the trade-off between gain in exposure versus loss in satisfaction. So we did some A/B test over the summers, and then we kind of quantified that, hey, you care about two things. On the x-axis, gain in exposure. So if you have some niche content or some casual music, you want to expose them more on the platform. And you also care about user satisfaction. So here we're quantifying the loss in satisfaction and the gain in exposure. So these are all like normalized so that like we're not like showing away. There is always a loss. That's a good question. I think these are relative in the sense that these are relative to one standard method. So we have picked up one of the methods. So it need not be always a loss. So I mean, they're not normalized based on 0 or something, and they're not normalized based on control as well. So again, like we have to be very careful in how we report these numbers so that we don't give away such type of insights. So you can look at the paper for the normalization details. But essentially, the takeaway over here is that things are all over the place, right? That some things are giving you less loss, but they're not giving you more gains. Some things are giving you more gains, but they're not giving you less loss, and so on. So I think that's a very important point, that this is a trade-off decisions which your models have to present. So it's not like a one model does everything kind of solution we are looking at. It's often that what model gives me enough options to choose from. So ideally, if I'm a researcher and I go to a product manager, I would want to present a buffet of models that, hey, if you want to do this, pick this up. If you want to do that, pick that up. And you're going to get these trade-off criteria based on which model or which parameter settings you decide to go ahead with. So again, that's a philosophical change in the kind of thinking we have, because now we're thinking of a buffet style solution rather than, hey, there's a one dish, which is a curry, which everybody has to eat. Cool. So again, I think that's the summary of fourth part, which is understanding users, suppliers, and contents. And essentially, like, understanding users helps us in pushing other objectives without hurting key user metrics. So it's still very early days around this. I think like a lot of work has to be still done at Spotify, at other companies, on how do we marry the part 3 of the tutorial and part 4, that we have insights about user and content and suppliers. We have some ML models which are multi-objective. How do we make them interact and talk to each other and then gain a lot from that? So in terms of users, we have talked about user heterogeneity. In terms of consumption diversity, we talked about user intent. We've talked about user receptivity. In terms of understanding suppliers, we have talked about supplier diversity, spillover effect, and we also talked about like content understanding. I'm gonna quickly, I should bring this. So yeah, so we are gonna now talk about the fifth and the final part about industrial applications. Every 48 yes, actually,